Okay, hello. So I have an example here. So here's our example. So the following data gives the population in a town over a period of 50 years. So I have the data table here, which looks amazing. I can't wait to graph this. And what we're going to be doing is we're actually going to have to find out what the exponential regression equation is that's going to represent this data. So what we're going to want to do first is we're going to want to make sure that we can go ahead and put this onto our graphing calculator. So the first thing that we're going to do is go to our graphing calculator, and you're going to press Stat, and then go to Edit, which is 1. So this brings you into one of your wonderful tables that you can have in your TI 83 or 84, whatever you might have. Okay? And what I did is I labeled the years first in L1 and then the population in L2. Well, why did I decide to put the years in L1? Well, the reason I did that is because when I'm looking at this, almost 100% of the time, our years are going to represent our independent variable. So they're going to represent what shows up on the x-axis, which leaves us with our population, which makes sense, right? The population is going to depend on the year, or what year it is, okay? So I went ahead and I do already have this in the table here, okay? And now what I want to do is I want to go ahead and graph this information. So in order to graph this information, what I'm going to go to do is press second, and then y equal. And what it does, it just brings you up all the stats so that you're able, or all the different plots that you can choose from. So I'm going to go to 1, I'm going to use that one. And you'll notice that right away, off is selected. So go ahead and select on. And for the type, you want to select a scatter plot. That's the first one with the points. Now the reason you don't want a line graph or a bar graph is that it doesn't properly show our data. So we're going to go ahead and select the graph there, the scatter plot. Now this is where you need to make sure that your x and y variables are labeled properly. So remember, I made my year the L1 part of my table. So in my X list, I have L1, and then Y list, which is population, L2. Now that I have that, I can go ahead and graph it, and you'll see mine turns out to be really nice, because I've already done this previously, just to save a little bit of time. So now that I have these points, what I want to do is I want to find the regression equation. Now, when we're going to find the regression equation, we first have to go back to our screen here. From here, you're going to press Statistics or Stat, and then you're going to move on over to Calc. And now, this screen is where you find all of the different types, or how to find all the different types of regression equations. Now, our question specifically asks us what to look for. Now in this case, it's exponential regression. So I'm going to go ahead and go look for exponential. Now in this case, I think it is 0. It is. So I'm going to exponential regression, 0, pressing enter. Again, X list and Y list, so L1 and L2, and then calculate. And here we have it. So here's our exponential regression equation. We have its y equals a times bx to the power of x. Now I'm just going to write this down. Now you're always going to want to go to 2 decimal places. Okay. So go ahead, going to record our information here. So I know that it's y equals a times b to the power of x. Now we're going to go ahead and substitute those values that we found. This is just a general form, right? So we have y equals 8,724.44 times 1.07 to the power of x. So this is our regression equation. Now it's also asking us if it's a growth function or a decay function. So when we're going to try to answer this, what we're looking for is our b value. So our b value tells us if it's growth or if it's decay. If it is larger than 1, then we have a growth function. If it is less than 1, it is a decay function. Now in this case we have 1.07, so this is a growth function. Okay. And that is because b is larger than 1. So there's your answer to it. Okay, so we have our wonderful regression equation, and now we're on to the next question. So we estimate the population to the nearest 1,000 after 35 years. So going back to my calculator here, and I need to graph this regression equation. So there's a really wonderful way, instead of just trying to punch it in what we have there to however many decimals so we get extremely accurate, there's a fantastic way to insert it into our calculator so that it just inputs as much information as possible. So we're going to go to our y equals, then I'm going to go to y1 equals. If you have anything there, clear it. You shouldn't have anything else there. The next thing that we're going to do is you press the bars button and go down to statistics, which is 5. From statistics, go over to the right and go over one more time until you're at EQ, and then select one reg equation. Now what this does is it inputs our A and B values directly into that y1 equals. So when it plots it, it's going to be as precise as it possibly can. So now I'm going to go ahead and I'm going to graph it. And lo and behold, I have this wonderful graph I've already gone through. Or I've kind of already created and set my parameters. If you have any issues and it's not showing up very nicely, go over to Window and then adjust your window accordingly. Okay? So going back to the graph. So I went ahead and I have it graphed here. Now the question is asking me, what is the population at 35 years? So the first thing I need to decide, well, is this going to be my x equals 35 or my y equals 35? And if I go back to my question, I find, well, I put year is equal to x. That's what I have up here. So what that means is, I'm looking for my y value when my x value is equal to 35. So then that's looking for that y coordinate when our x coordinate is 35. So what we do on the calculator is we press second function and trace, and it brings you to the screen, and we're going to go to value, which is 1. Okay, so you'll see that x equals, and then it's blinking there, and what we're going to do is put in our x value, which is 35, and then just hit enter. Now what this does is it brings you to where the x coordinate is along our regression equation. So at x equals 35, we have y is equal to 81,449, because it's to the nearest 1,000. Okay, so I'm going to go ahead and I'm going to write that down and record it. So my answer is 81,449, which is really fantastic. So it is more of a word problem, so in this case I need a word answer. So the population is approximately, remember to put approximately because it's not exactly, 81,449. After 35 years. All right, so there we go, we have it. It's wonderful. Now let's go on to the last part of this question here, C. So if the population continues to grow at this rate, sorry about the typo, predict in which year the population will reach 500,000. So now I have to decide again, okay, well, is this going to be an X or a Y? Is it population dependent or independent? Sorry, I guess I should say independent or dependent. Now, since it has population, we've already determined what that was earlier, right? So population, well, that's RY. Looking up here, we've decided that previously. So as we go about this, so we see Y equals 500,000. Okay, so now we have to actually go and input into our calculator. Now, we're not going to do the same thing as the question B there and press second calc and then just put in 35 because that's for our X value. For our Y values, what we're actually going to be doing is you go to Y1 and then, or you press the Y equals button and you go down to Y2 and then put in the value for Y that you have, what you're looking for. In this case, it's 500,000. Well, there we go. So now that I have that, I'm going to go ahead and graph it. So it's loading, and you'll notice, oh no, nothing is showing up. Okay, well, if nothing's showing up, that must be my window. So I'm going to go to my window and check everything out. It's not showing up in my y-axis there, and oh, look at that. My y maximum is 400,000. So that's smaller than 500,000, so it doesn't work. So I'm going to change that so it is more than 500,000. Maybe 550,000. And we're going to go ahead and graph it again. So how did I come up with the y max? I'm just estimating what number I think would work. So I'm just going for a number larger than that y value that we're trying to search for. So here we have both graphs. And now to find our answer, what we're going to look for is the intersect. So we're looking when these two graphs cross each other. Now in order to find that, what we're going to do is we're going to press second, and then calc, and we're going to look for intersect, which in this case is 5. So I go ahead and press 5. So it's asking for the first curve. Here, top it shows I'm on Y1, so I'm pressing enter. Then I have Y2, enter, and then it asks you to guess. So you just move that cursor over to where you think it's going to cross over, or where it's going to intersect, and then press enter. And there we go, we have our answer. So you'll notice that the y-axis is, well, what we're trying to find. Well, the year at the population of 500,000. And then it gives us our x coordinate, which is 63.43. So that's how many years, approximately, until there's a population of 500,000. So we'll write that down. X equals 63.43 years. So since it is a word question, I do need a word answer. So in this case, it will take 63.43 years for the population to grow to 500,000. All right. There is one thing that I actually missed there, and it's right here where it says it will take 63.43 years. This should be approximate. And the reason we're putting it in is because we're just following a rate from a regression equation that fits the data the best that it can, but it doesn't necessarily mean that is in fact the rate for population growth.